So I hope you people can able to see my screen now, and if anybody could not able to see, please let me know. So starting with the today's class, the first class in fact with DBA. So we are going to understand first about the operating system functionality, and based on that we are going to learn about the architecture of Oracle database. So first, you can see the diagrams on the screen right now. There are two diagrams. So the above diagram or the first diagram is going to talk about the operating system functionality, and the below diagram talks about how Oracle database behaves. So first, let us go and try to understand the first diagram. So whenever any user requests for some information to the operating system, usually what happens is operating system will first check whether that information is available in the RAM or not, and if that information is available in the RAM, then it will be given to the user. So what I say when what is mean by request here. So let's say you are double clicking on a song, or you are double clicking on a video file, or you are double clicking on a Word document or anything. Okay, so every double click that you do, or every enter button you do, so that will be considered as a request to the operating system. So this request will go to operating system, and what operating system will do is, whatever the file you are asking for or whatever the information you are asking for, it is going to check whether this information is already available in the RAM or not. For example, here you can see my screen. Suppose I am double clicking on let's say, okay. So let's say I am double clicking on this particular Word document. Then what happens is, the moment I double click, first operating system will check whether this information is there in the RAM or not, and if not, if the file is readily available in the RAM, it will be given to the user, or otherwise it is going to search from the hard disk. So as per the diagram you can see here, first it is going to check in the RAM, and so first it is going to check in RAM, and if the information is not available in RAM, then it is going to pick up that file from the hard disk. And after picking up the file from the hard disk, what it is going to do is, operating system is going to place a copy of that file into RAM. And once that copy was done, then that file will be given to the end user. So this is when the file is not available in the RAM. So as I said, if the file is available in the RAM, it will be given to the user. If the file is not available, then it is going to search in the hard disk, and it is going to place a copy in the RAM, and then finally it will be given to the end user. So that is what it is going to do when you are requesting for some information. And now, when we gone through this kind of concept, usually we will get with a lot of queries. So same, starting with the first question, like, how much, why we need to maintain a copy in the RAM. As I said, if the information is not available in the RAM, then operating system is going to copy that into RAM from the hard disk. So the question is, why we require to place that copy in the RAM? So the reason is, you are going to, the second time when you are going to try access that file, you will be observing that the file will be retrieved faster. So most of the times this, every one of us might have experienced already with this, that when you double click on a file first time, it will take some time to open, and when you double click on the second time, it is going to retrieve faster than first time. So this is because first time the copy is not available in the RAM, and the second time the copy is already there in the RAM, and that is the reason it is going to give you the information quickly. So the first question that we understood is, why it is going to maintain a copy in the RAM. So the answer would be to give better access or the faster access for the next coming request. So that is the first question. And the number two, the question number two is, what happens if the data size is more than the RAM size? So I am taking an example to explain this. For example, let's say your RAM size is 1 GB and you double clicked on a DVD file. So usually, DVD movies will be of 3 GB or 4 GB sizes. So let's assume a case where you double clicked on a movie file which is of 4 GB. So now what usually, as per the first point that we understood, operating system need to copy this video file into RAM. Then from the RAM it is going to start playing your video. Now your RAM size is only 1 GB, but the file you double clicked is of 4 GB. So definitely 4 GB of data cannot be fit into 1 GB RAM. So in this kind of situation, what operating system is going to do? So operating system will split down all your or your entire 4 GB file into 4 1 GBs or multiple parts, I say. So every time what operating system will do is it will copy the part, to say whatever the part of the movie you are watching, it is going to copy that part into RAM, and whatever the part already you watched, so that portion of the movie will be again pushed into hard disk. So it is going to keep on rotating these things. So first it is going to copy the content, and then the already watched content will be moved back to hard disk, and whatever the new portion of the movie that you want, it will be again copied into the RAM. And this kind of, so basically what operating system is doing here is older data it is rotating with the new data, and this process we call it as swapping. So in Unix we are going to call that as swapping, and in Windows we call the same concept as paging. So either you call with different names in different operating systems, but ultimately the concept is same, that you are going to rotate the older data with the new data, or you are going to swap older data with new data. And when this things are being going on, let's say you are watching some portion of the movie, and all of a sudden you want to watch a particular song or a particular scene, or which would be your favorite scene, and you drag the cursor, let's say in Windows Media Player or any other media player, you just drag the cursor to the older portion. Then you would be observing that there would be some 2 or 3 seconds delay in starting the video playing, and after 2 or 3 seconds that media player will start playing your particular scene or particular song what you have requested for. So I hope everybody might have you observed this thing, that when you are watching a movie and suddenly if you drag back, it will take a pause of 1 or 2 seconds, then it will start playing out. So why that pause of 1 or 2 seconds is being taken is because that whatever the data you asked for is old data, and as I said, old data has already been flushed to hard disk. So when you drag your cursor back, what happens is basically you are asking for older data. Then then operating system need to flush the new portion what you are watching right now, and it need to pick up the older portion from the hard disk. So that's the reason the 2 or 3 seconds time gap would be there. So that is what basically happens when the data size is more than the RAM size. Now if you have RAM size in particular, I mean to say, let's say your video file is of 4 GB size and your RAM size is also 4 GB, then you don't require this kind of swapping, and you can fit your entire 4 GB into this particular RAM, and automatically things will start working out smoothly. And that means swapping is a bad habit for operating system. So as a DBA, so what is the primary goal for DBAs is to reduce this swapping as much as possible. Sometimes you can't avoid it, But at least if you can't avoid it, you need to try to reduce the swapping as much as possible. And how we can achieve that? By using a better RAM size, all those things. And when it comes to Oracle terminology, or even in OS terminology also, instead of calling them as a swapping, we also call it as performing an IO, that is one input and one output. So the basic fundamental rule says is more number of IOs will lead to the performance issues in the system, or more number of IOs is equals to less performance. So this is the ground rule that we are going to follow. Either it could be an operating system or it could be an Oracle database, but the ground rule remains same. So first question what we have seen is why to maintain a copy, and second question is what happens if the data size is more than RAM size, and the answer is swapping is going to take place. And as I said, swapping is a bad thing that happens to the operating system. So we should avoid swapping as much as possible, and that is possible only by increasing the RAM size. And the third question that we have is how the data in the RAM will be managed, because let's say different requests, even if you see my screen right now, I'm not sure whether you can able to see it properly or not. So if you can see my screen now, I have Mozilla browser open, I have some VMware open, I have this GoToMeeting thing, and I have a folder open, then a PowerPoint presentation and a Word document. So now I have opened so many applications basically. So when I open these many applications, definitely each and every application will consume some amount of memory from RAM. Now in this kind of situation, how that memory will be managed in the RAM. So the memory in the RAM will always be managed with the help of a algorithm called least recently used algorithm, or shortly we call it as LRU algorithm. So LRU stands for least recently used. So what is that mean is, whenever you are trying to open a new application, and if operating system couldn't able to allocate sufficient RAM to that application, then operating system will remove one of the application which you have opened very long time back. Suppose 1 hour ago you have opened one application, and right now you are not using that, and recently you have opened one application. To adjust the memory, what operating system will do is, it will remove the content of older application which is running from last 1 hour. So this is to adjust the memory or to adjust the RAM size to all the applications. Operating system is going to follow this algorithm, especially for RAM. So that is how we have the third question, how the data in the RAM will be managed, and the answer is least recently used algorithm. So have you guys understood about what I am trying to say? Any questions and all, you can ask me. So we have some questions from Raghu. Okay, CPU speed is measured by gigahertz, exactly, and in real time, what would be the sizes? In real time, yeah, actually we would nowadays we are not actually measuring by gigahertz or any other thing. So nowadays we are working on something like how many number of CPUs are there. So whatever you said, measuring the CPU in gigahertz is older one, when we are using Pentium 3 machines or Pentium 4 machines. After that, we have launched with the Core 2 Duo or dual core machines, and now you have i3. Intel is having three different processors like i3, i5, i7. So what is that exactly mean is you are going to have those many CPUs. So now it is not like only one CPU will be there. You will be having multiple CPUs even in your laptops or PCs. So definitely if you have multiple CPUs in PCs or laptop itself, then when you go to servers, you will be seeing a much more bigger value. For example, um, the servers will be having a minimum of 8 CPUs. CPUs count will be 8. So the processing power will be very high, in fact. And the other question, what was asked, like any names that I can provide for real-time processors. Frankly, as a DBA, we will never go and check what is the processor name or what is the hardware we are using and all, because it is the task of a Unix admin more than a DBA. So that's the reason I have never checked, what is the processor name and all. So because for DBAs, it's none of business, frankly. And yes, swap, whatever the swapping concept that we talked about in Linux, so we call it as virtual memory in Windows. So hope that answered your questions, Raghu. Okay. Yeah, we have a question from Sanjay. I hope everybody can see in the chat window. So the memory that would be minimum, in real time for servers would be 16 GB, or I can say if you take lower end servers, it would be minimum 8 GB. But I don't think nowadays servers are coming with the 8 GB, because in laptops or PCs itself we are using 8 GB. So I cannot say the new servers which are building up are not going with 8 GB. It is going more than that. 16 GB will be the minimum value, and it can go till 200 GB or 300 GB of RAM size. So if you take very big server, it may have 300 GB or 400 GB RAM size also. So, and out of which how much DBS would be needed is dependent on how many databases you are creating. Suppose in one server you are creating only one database, then the ground rule which we follow is 40% of the RAM size you would be taking for Oracle database. For example, you have a 10 GB RAM, let's say. So, and when you are creating only one database in that server, out of 10 GB, 40% you will be taking it for Oracle database. That means 4 GB. So 4 GB you are going to utilize for your Oracle database. So the rest of the 6 GB you would be leaving it for some part you would be leaving it for operating system, and some part you are leaving in order to use at a later point of time. So, but in the same server, suppose you are going to create a second database, then you cannot follow this 40% rule. So when we discuss about those memory things and all, I will explain more clearly. Yeah, hard disk, like minimum would be 1 TB, I can say, because nowadays even in our PCs or laptops we are having that, and maximum it will be into exabytes. So it will not be into terabytes, it will be into exabytes or any other. So crossing petabytes, like terabytes, petabytes and exabytes, so it will cross that one. And we have septabytes. So septabytes is something like 2 to the power of 7. So we have septabytes in place. Like if you take Facebook or Twitter or any other social networking sites, so especially they are growing very fast, and their size is into septabytes now. So any questions related to the concept of the what we discussed? Okay, it depends, Sanjay, frankly, for a virtual machine of Linux in real time, it depends on purely how many virtual machines you are going to create on the physical server and what is the RAM available. For suppose you have 32 GB RAM and you want to create two virtual machines, then out of 32 you would be allocating somewhere 12 GB and 12 GB. So it would be like something like 24 GB you would be allocating for virtual machines, and the rest of the thing you would be allocating for your host operating system. And all these will go by how many machines you are creating or how many databases you are creating. So it depends on those factors. So any other queries we have? Okay, so now let us go and talk about how are or what our Oracle database contains, what are all the components it contains, and how it is going to behave. So if you look at the diagram, I hope everybody can able to see the screen. So if you look at the diagram here, basically Oracle database is having two components. One we call it as instance, and the second one we call it as database. And even if you correlate with the first diagram, you can see both are similar or both are almost same. So that means the functionality of Oracle database will be exactly similar to your operating system only. That means here also what happens is whenever user requests for some information, so in operating system you will be requesting the information by doing a double click or by executing a command or so. But when it comes to Oracle, how you would be requesting for the information? Using SQL language. It could be a select statement, it could be a DML, DDL, or any other language. So you will be using basically SQL language in order to request the information. So let's take an example that a user issued select star from EMP. Then what Oracle will do? So just like operating system, the request which the request which user has issued, this request will be sent to Oracle side, and we have a component called instance, and what Oracle will do is it will check whether the data is readily available regarding this EMP table in the instance or not. So as I said, user has issued select star from EMP, that means user wants EMP data. So what Oracle will do is it will verify in the instance whether this EMP table data is available or not. And if the data is available, that will be given to the end user, that means it will be displayed on the screen of the user, or otherwise Oracle is going to search for the data in the database, and the moment it finds the data, it is going to copy that into instance. So just like how our operating system is working, in the same fashion, once the data is available, it is going to copy in the instance, and from there it will be given to the end user. So this is what it is going to do. And again, because it is exactly behaving like our operating system, again those three questions will come into picture, like why to maintain a copy in the instance. The answer would be it will give benefit for the next coming users. And what happens if the data size is more than the instance size? And again, as I said, the swapping, or we call it as IO, will take place, and which is actually a bad thing that happens to Oracle database. And the third question, how the data inside the instance will be managed with the help of least recently used algorithm. So whatever the concept we saw in operating system, exactly the same will be there in the database concept or database functionality also. So any queries? Now, what exactly is this instance and what exactly is this database? Now, database means it is a area or it is a location where you are going to store the data. So, it's something like you want to store some tables, and under tables you want to store some rows, and database is the place where those tables and data will be stored. Then what about instance? Because we never heard about what is mean by instance. Now, to write into this instance, to write into the database, so write in the sense, suppose you perform some DML transactions or DDL transactions, like you updated some data. So in such case, let's say you updated a salary from 10,000 to 20,000. Now this the new value here will be 20,000. So Oracle need to write this 20,000 into database, or somebody should go into database and update this value from 10,000 to 20,000. So who is that someone is a component, we call it as background process in the instance. So instance, the definition of instance says it is a component which will help in reading the data from the database or writing the data into the database. So either you want to read the data or you want to write the data into the database, you need to go through the instance. So without instance, you cannot access the database directly. Just like without RAM, how you cannot access your hard disk, even in the same fashion, you cannot access your database without instance. So any queries we have? Okay. So now when you elaborate your diagram, Oracle architecture diagram, so this is what you are going to see in the picture. Of course, it's very large diagram in fact. So when you elaborate your instance is this one, what you are going to see on the screen, and your database is nothing but this one which you are seeing on the screen. So this much bigger components that we have. So what is our goal is the next coming 3 to 4 days we are going to understand about each and every component that you saw in the instance as well as in the database. So we are trying to understand what exactly a shared pool is, or what exactly is library cache is, etc., etc. So we are going to learn about that. So as part of that, let us start with a topic. So like how the user connectivity will takes place in the database. So everybody might have every one of you might have already used Scott and its password in order to connect to the database. So normally when you type Scott/Tiger and when you hit enter button, what happens is you will be getting a SQL prompt. So if you have typed your password correct or username correct, and then you will be getting a SQL prompt. Otherwise you will be getting a acknowledgement saying that invalid username or password. Now today we are going to understand how this user connectivity will be taking place in the database. So we are going to understand about that. And as in the diagram you can see on the left hand side, left hand top, there is a process that is sitting over here which we are going to call it as user process. So what exactly is a user process? Or before going for user process, what could be a process? So we have discussed this in Unix class also. A process is nothing but a series of actions. So if you are performing some actions one by one, then you can call entire thing as a process. So even user process is having some definition, and what that definition says is it is a process which will be created whenever you start some application. So that application could be a SQL plus window, or that application could be a Java application, or that one could be a web application, whatever it is. So whatever it is, when you start something, and in the background there will be a user process created. Now to explain it better, here I open PowerPoint presentation, so you can see that. And if I go to task manager here, I hope you people can see my screen. So if I go to task manager and click on this processes, then you will be seeing a PowerPoint.exe process running. So can everybody able to see this? I hope so. Okay, so this we call it as user process. Because I started my PowerPoint presentation, this process is running in the background. For example, let me close this PowerPoint presentation. I am clicking on close window button, and you can see that process is gone. So this is what actually happens in the background for everything, not only for the PowerPoint that I am talking about. For example, if I open a notepad, immediately you will be seeing a process running by the name notepad.exe. So you can see here. And if I close that notepad, then automatically that process also will go away. So, all the processes which are running here, we call them as user process. So everybody got an idea what exactly is the user process and what I am trying to say? So any process that will be created when you start some application, we call it as user process. And what is in Oracle, what is the responsibility of a user process? User process is going to send out the login credentials to Oracle database. Now, how you are able to connect to the database when you give /tiger? Because some authentication need to be performed. Because without authentication, no database, or at least in today's world, without authentication, no application is also working. So definitely the username and the password are must in order to access the database. So what this user process is going to do is, after you start some application, you will be providing your username and password. So this username and password will be sent to Oracle database for verification, and that is the responsibility of user process. So what it will do, it will collect the username and password from the application, and it is going to send this information to the server side or to Oracle database. And on the database side, so if you look at on the database side, there will be a component called listener. So you can see an arrow mark, and you can see a gray color bar over there. So we call it as a listener. So what exactly is this listener is? Listener is like a door that you have in front of the database. So suppose you want to enter into a room or you want to enter into a house, definitely you should have that door open. And until unless you don't have that door open, you will not be able to enter into that particular home. Like the same way, if listener is allowing the connection, then only you can able to connect to the database. And if listener is not there, or if listener is not accepting your connection, then it is not possible for you to enter into the database. So listener is just like a door that stands in front of a house or in front of a home. And normally, if you want to open the door, it cannot be done just like that, right? So if you want to open a door, then you need to unlock it. There will be a key, and with that help of key, you are going to unlock the door, and then only it will be open. So the same way, here also you need to unlock your listener. And how that will happen is with the help of username and password that you are providing from the user process. So as I said already, user process responsibility is to send the username and password to the database side. And when you pass this information to the database side, this listener is going to accept that, and it is going to open the door for you in order to connect to the database or in order to go to the database. And once listener will receive this information like the what is the username and what is the password, then listener is going to send this information to one of a background process. We call them generally as a background process, which are highly critical for our database functionality. So listener is going to hand over this information, like what information? The username and the password. So listener is going to hand over that information to PMON. So there is a background process, we call it as PMON, and full form is process monitor. So what this PMON or process monitor background process is going to do, it is going to check or it is going to do the authentication. So authentication is nothing but basically verifying the username and the password, and that is what PMON is going to do. So any questions over here before we proceed for further points? Okay. So once PMON receives the information like what is the username and what is the password, now the major problem for Oracle database here is because normally as human beings we have brains, so we can remember that tiger is the password of Scott user, or first of all we can remember that Scott is the username and tiger is the password because we have brains and we can remember it. But for Oracle database it's not like that. Oracle doesn't have any brain. It is just a software which can't remember what is the username and what is the password and all. So then how Oracle is going to maintain that information? Oracle will maintain all this information pertaining to its database in something called base tables. So we have some kind of tables which are created inside the database, and we call them as base tables. So because those tables are the base for your database functionality, and in our case this information regarding the username and the password will be maintained in one database. So for different purposes there will be different base tables created. For example, to store the user information there will be one base table created, or to store the table information there will be one more base table created, or to store index information one more base table, or to store how much memory that was allocated to Oracle database, even that will be also there in one base table. So exactly we can say base tables are something like dictionary. Suppose you don't know something, you don't know the meaning of a word, what you generally do is you would be referring to a dictionary, right? So the same way, because Oracle can't remember everything, it will maintain a dictionary, and that dictionary we are going to call it as base tables. So what PMON is going to do here is, now here PMON will just follow the operating system functionality. So what operating system or Oracle will do? Here PMON has received some request for the listener, and generally just now we discussed that point that whenever you receive some request, initially the search will be done in the instance. So what PMON will do is, PMON will verify whether the base tables that are required are there in the instance or not. And in instance, it is going to check that information in a particular component called data dictionary cache. So what PMON will do is, after it gets the listener information, after it gets the information from the listener, it will straight away go to data dictionary cache. And in data dictionary cache, it will verify whether the base tables are available or not. And suppose if the base tables are not available, and in such case PMON is going to come to database. So as you can see in the arrow here, If first Pmon will go to data dictionary cache, it will verify whether the base tables are available or not. If not, Pmon will come down to database and it will search for the base tables. And once it gets the information like what are all the base tables required, it will copy all of those base tables to the data dictionary cache. So just like the same functionality like what operating system will do. Operating system, first it will check in the RAM itself. If the information is not available, it will come down to hard disk and then it is going to place a copy. So in the same manner, Pmon will first check for the base tables in data dictionary cache. If not, it will come down to database and from database it will copy the required base tables to data dictionary cache. And once these base tables are placed in data dictionary cache, then Pmon will do the authentication. So authentication is nothing but verifying whether this is the correct username or not, or whether this is the correct password for this user or not. So once this is done, then Pmon is going to send an acknowledgement directly to the user process. So you can see a arrow mark over there. So Pmon, after the authentication, it is going to send an acknowledgement to the user process. Now this acknowledgement either could be a successful acknowledgement or a failure acknowledgement. That means suppose the authentication is successful, then Pmon will send a successful acknowledgement saying that yes, your connection is agreed, and if not, Pmon is going to send an unsuccessful acknowledgement, like it will throw you a message like access denied or invalid username or password or insufficient privileges, etc., etc. But if it is a failure acknowledgement, then Pmon will stop its work there, because the problem is there from the user process side. Not there is no problem from the database side. The problem is there from the user process side. Either you have not provided the correct username or you have not provided the correct password also. So you need to rework on that again. But if it is a successful acknowledgement, so the authentication is successful and you are authorized user, then as a final step, Pmon is going to create something called server process here. So we have a process here created. So we call it as a server process. So what Pmon will do is it is going to create a server process there. So what exactly is a server process and how it is going to help us? Server process, the definition of server process says, server process is going to work on behalf of user process and it is going to do the actual work. Suppose after the connection got established, user process set select star from EMP. That means user process wants to retrieve the data from the EMP table. Then who is going to actually process this information and get the data and all is server process. So that is the reason the definition says server process is going to be created by Pmon and it is going to work on behalf of user process. So here by this we can understand that user process is only a requester and server process is the one which is implementer. So I can give an example for this. Let's say you want some information from some city. Let's say you want to apply for a particular MBA program, or you want to apply for a CAT or something in a particular university and all, and you couldn't able to travel there, or something is not possible for you to travel there and apply that. I applied or to get an application. So what you would be doing is generally you would be requesting your friend or relative to help it out. So in the same way, here also user process can't go directly to the database. Instead, it will take the help of the server process. So server process is the one which will actually do the work on behalf of user process. And this server process will be created only when the acknowledgement is successful or the connection is successful. If the connection is failure, then this server process will not be there. So that is what will happen in the user connectivity part. So anybody is having any queries, please either you can speak out or you can type in the chat window. So nobody is having any queries. Okay. So once the successful acknowledgement was sent to user process and the server process got created, then once the connection has been established, then we don't require this listener. So that means the connection got established means you are already entered into home. So let's say you open the door, you enter the home, and everything is successful. So when you are in the home, you don't actually require the door to be there or the door to be closed or something. So that's the reason when the successful connection got established, then you would be seeing your architecture diagram like this, where you can see here there is no listener standing. So user process is directly talking to server process, and server process is indeed connecting to the instance and all. So that is how the diagram will change, and this is when the connection is successful. And here under server process you can see a component called PGA. So what exactly is a PGA? So before going for that, I want to tell you one point or show you one point. Like every process that you would be running in the system, that process will take some CPU and memory. And I hope everybody can able to see my screen now. As you can see here, there are some processes listed down, and all these processes are consuming some CPU and memory. Of course, some processes may not require to consume some CPU. They will take only memory, depends on the functionality, and some processes will take both. So if you look at the first process here, go to meeting. So this go to meeting, when I invoke it, even for that also one background process will be there. So G2M is nothing but go to meeting, and COMM stands for communication.exe. It is taking 7% or 9%, that is fluctuating actually, you can see there. So it is consuming some CPU as well as it is taking some memory also. So almost it's taking 120 MB of RAM size. And next you have Firefox. Even though that Firefox.exe is not taking any CPU, but it is still taking 113 MB of RAM. So like this, every process will have some CPU and memory allocated. Now coming to our Oracle architecture, is having so many processes, as you can see here. Like user process is there, server process is there. Just now we talked about one background process called process monitor. So whatever the oval shape diagrams that you are seeing here, all these considered as processes, and every process will consume definitely a CPU and memory. That means user process will have its own CPU and memory, server process will have its own CPU and memory, like all these background process including PMON also will have its own CPU and memory. But for all of the other processes, even though they contain some memory, Oracle has not given any name in specific. But for the memory area of server process, Oracle has given some particular name, and we call it as PGA. And PGA stands for Private Global Area, or some people will call it as Program Global Area. So what is PGA? It is a memory area that is allocated to server process. As I said, for every process there will be a memory allocated, but due to some reason only for server process memory area there was a name given by Oracle. And why that much special treatment is there for server process, we will be understanding down the line when we discuss more things about architecture. So that is what PGA is. It is the memory area that was allocated to server process. And more about PGA we will be discussing at in future classes. So anyone is having any queries? Okay. And one more thing is whatever we have been discussing, so all these contents will be there in the class notes.